Welcome everybody to this webinar about blockchain for the food industry in the DIKU Business Club's Computer Science Impact for Industry series. It's nice to see so many people from all over the world, from Philippines, Malaysia, Ethiopia, Denmark, and many other places. My name is Skött. I'm head of business and innovation at the Department of Computer Science at the University of Copenhagen. The webinar is organized together with Inbiom and Food and Bio Cluster. Iversen from Food and Bio Cluster will tell you a little bit more about Food and Bio Cluster later in the webinar. So first of all, a little bit about DIKU. We of course a computer science department. So we have some core disciplines in computer science. You can see some of them here, and some strategic themes. And you see them here, and one of them is sustainability, where today's theme is very relevant. I'm looking forward to the presentations today and also about this topic. On to the program, and I see that Anders has joined us from the Food and Bio Cluster. So we're gonna do the program you see here. In a few minutes, I will give the word to Anders from Food and Bio Cluster. I'm looking forward to hear about this new Food and Bio Cluster in Denmark that covers both the food industry and the biomass sector, sector for bioresources. And after Anders, we'll hear a presentation from Fritz Henglein, who will give us some food for thought, or blockchain for food, as it says, on some of the work they've been doing with Peter Larsen Kaffe and other stuff they're doing in blockchain. Ravn, who's CEO of SEGES Digital, national Danish food industry research think tank. You must find the right name for it. Ivar is widely known in Denmark, but outside of Denmark, I don't think it's that known. And you've been quoted recently in the press that the use of blockchain will take longer than expected. So I'm looking forward to hear more about the food industry's use of blockchain. We'll take a short break, and then Lars Aaen Thøgersen from Peter Larsen Kaffe will join us to tell more about the project they're doing with DIKU from a business side and sustainability side. I'm looking forward to that. So, with no further ado, I'll give the word to Anders.
I'll tell a few things about the Food and Bio Cluster Denmark. I have made this brief lifespan overview. So if you, all the main issues are here. So Food and Bio Cluster Denmark is industry initiatives that together with the universities and local governments have formed this new supercluster. It's newly merged this summer 2020 and recently, last week actually, approved by the Ministry of Higher Education and Science in Denmark. We now cover, I just checked the number today, we just reached 300 industry members, and in total we cover around 82% of the total turnover of the Danish food production. Of course, this is due to that we have many of the very large food producers, so that's the reason for that. And we financed via member fees, grants, and projects. So our mission, I will not go very much into that, but we are looking very much into these UN world goals. So we are together with our members looking into those. Our value chain is covering in the entirety of from agriculture, the primary production, aquaponics, fishery, forestrations, animal production, and so forth. And I apologize for this, it's actually in Danish, I just realized now. But anyways, this is a highly political industry, so we need solid data and good projects to make good decisions. And this is part of the reason data that we have, reason for being, that we should link industry partners and universities. So what are our target groups? Businesses and companies are our main target group, and the areas that we operate within is as mentioned before, plant production, animal production, bioenergy, forestation, aquaculture, and vertical farming or urban farming, with all these issues below them. The services we provide, and I have put out 3 that I'll just go slightly in detail with, but overall our services are matchmaking with researchers and industry partners is one of our key components. We host different kind of technical networks. We are project manager in a lot of projects. We support early startups and entrepreneurs. We support with cascade funding, that is especially for SMEs. We often have communication and dissemination obligations. We support Danish companies for export and access to relevant staff for our members. So these are all key issues if you want to be a supercluster like Food and Biocluster Denmark. I'll not go into details with these clusters or these networks that we, but just mention that Danish insect network is the largest one in the world of its kind. One of the things, and today is actually a good example of that, but we have these food innovation talks that we have done for quite a while, 30 minutes live stream for our members. And this gives an opportunity to showcase your company and share knowledge. And that's actually all we are about, sharing knowledge between industry partners and universities. This is very briefly, I'll just highlight one example of our cascade funding, S3 Food, where we apply for 5 million euros and reimburse SMEs with vouchers from 15,000 to 60,000 euros. So if you are a company, this is a way to find funding for your development. And if you're not a Danish company, that's not a problem, because if you're a member of Food and Biocluster Denmark, you are still eligible for these cascade funding. So that was just a brief, and yeah, all of Europe is part of these projects. And in this special case, we are from 8 countries and 13 partners. So this is the team. In total, we are 45 employees, but working within agriculture and bioresources, we are these 8 guys. Thanks, that was all.
So first a little bit about myself. I'm a professor of computer science in programming languages and systems, working in very foundational aspects, but also applications, and worked in various areas. So we've worked with contract technology and blockchain technology broadly for many years. So the first thing I wanted to do is actually give an introduction of what I mean, at least, and I hope actually we'll get to an agreement as to blockchain and how it is perceived. So first of all, as a topic, blockchain is widely spread out on the Gartner hype cycle. So it's from anywhere from being in the disappointment phase when it comes to so-called ICOs, to like general blockchain, to actually very smart contracts or blockchain supply chain. As you can see, it's a very topical thing. And remember, it's a hype cycle in the sense that there's a lot of focus on it and an exploration of the potential. And it has actually matured over the last years. So having said that, let's think about, when people say blockchain, I have to say that the first thing is, like, I try to have a conversation to understand what people mean by blockchain, because there's different kinds of senses and perspectives and interpretations of it. So I'm a little bit facetious in the following, but let's look at this. So the orthodox view, and this is where the term comes from, is from Bitcoin and Ethereum. Okay, so you will find actually lots of people who will say, like, blockchain is basically referencing to systems like Bitcoin and Ethereum. So these are 2 distributed systems with anonymous participants, highly replicated, and they have a cryptocurrency, and that's the key thing about them. Now, there's a more loose, interpretation of it, loose in the sense of a more general one. So in practice, very often you might find, well, okay, this is maybe a picture of what, you shouldn't be able to see this even, as this like a replicated state machine, and there's kind of like pointers to each other. And this is what you may have seen when people talk about blockchain and Bitcoin in particular, but also Ethereum as a platform for executing programs on this network of computers. So a more popular view is that I found very often is the following one. It's used in the sense of it's got something to do with things like Merkle trees, and sometimes people don't really know what that means. So it's something about, you know, cryptographic hashing, and then terms like wallets pop up, and that's terminology might be a little bit misleading. Wallets are nothing else but digital managed personal containers of private keys. So it always sounds like there is some stuff in there in the wallets, but there's actually, the stuff is not in the wallets. There's only you know, an access code to get to the real stuff. I mean, whatever it is, cryptocurrencies. And there's of course a network of computers, and it has something to do with cryptocurrencies. That's rather diffuse. So I'd rather present you know, a modern view of it. So so sometimes this is called distributed ledger technology view. So just to emphasize that it's not just the classical systems that were built on and where the name comes from, but also modern systems that do these things. So it's basically not any kind of fixed system, but it's a computer system that consists of a network of computers. So I don't know if you can see my pointer. I hope you can. So it's a peer-to-peer computer network. So it's network computers. So the most obvious computer network we have in the world, it's so obvious nowadays that people forget it's actually a peer-to-peer computer network, is the internet. Okay, so the internet has a dynamic number of computer nodes on it. Dynamic means, like, you know, nobody's getting permission or giving centrally permission to be on the network. You can join it, and it's peer-to-peer. The systems, the individual nodes as they're called, they communicate with each other, but there's some properties you want. So think of it as like, you know, it's a peer-to-peer network. It's computers. They can, you know, the edges mean they can send messages to each other. But they do the thing is like, the key thing is like, even though it's a network, to a user of it, even to a programmer, it looks like it's a single reliable virtual computer. So virtual means like when you program it, it's as if you were programming one big computer, sometimes called a world computer. Okay, you might want to be old fashioned, say it's like a mainframe. Okay, but that's not a modern terminology. So the key thing is like it's doing two things. Namely, it's this whole network looks like a single computer, yet that single computer is not run by a single company or person, or it's still run by all the members that run the individual nodes, and they're independent of each other. So a way of saying this is that it has decentralized governance. So there's many, it could be arbitrarily many, sometimes anonymous, sometimes they're a consortium of participants, they know each other and you have to join the club, and these are called permission systems. But it's not just a single provider, okay? It's not just a single cloud provider, it's not a single agent that then has privileged access to the data on it. So it behaves like a single, so imagine this is like, you know, a single computer here, and this is your computer communicating with this virtual computer, which doesn't really exist in reality. In reality, it's complicated underlying stuff, you know, consensus protocols you may have heard of and so on, that make this network look like it were a single computer. So there's two key aspects that you know, a blockchain brought to it. This is actually one aspect of blockchain. It's like it's a way of recording in a tamper-proof fashion digitally signed real-world events. So what that means is data. Somebody makes some data. Usually these things originally were like I want to transfer money to Anna's, for example. So I will sign it off and say, okay, it gets logged, and then it has happened on that one. But it could be other data, like, for example, I have delivered 5 kilograms of coffee to to Anna's. Okay, so it's think of it, that's the same thing, and I'll sign it off, and then it will be recorded, and it's tamper-proof in the sense that somebody from later on can check that this was actually recorded and was not changed. So the important part is that it wasn't changed. And our modern interpretation is like, since these can be real world events, you can associate evidence with it. So not just my digital signature, but maybe a picture or DNA or X-ray data that support that this digital recorded event actually reflects a real world event. That's very important for the applications we have in the area of food, where we don't just deal with money as a digital asset, but with real things. So the second thing is securely managing economic resources. It's very abstract. What that really means is we have things and money, and securely managing means that they're not duplicated. So we can, in this virtual computer, so remember, it's everybody's running their own computer, and still it is not possible for anybody to do stuff that you would usually do, is like copy data. The copying will be recognized as something that's illegal. So it guarantees that the data stored and that represent resources like coffee or money, they are securely stored and transferred. But transfer means that they disappear from the ownership of one party, and they're actually then the sole ownership of the other party. So they're not duplicated. And this includes things like, that is usually not done in blockchain applications, but that we've done here is transportation of goods from one location to the other. They can't be in two locations. And transformation of economic resources. That's rather new in the sense that we can guarantee that things that have been produced cannot be, they must consume resources. Otherwise, you can't take the same resources and produce two different things from it, okay? So this would be a way of forging real resources. So, and by highlighting goods here, you gotta think here as goods as food, commodity or non-commodity items. They can be highly specialized things, individual items that can track at the bean level if you want to, or they can be fungible, which means like, okay, I'm tracking 5 kilograms of coffee. So, but it's the 5 kilograms I have. So what this provides, and this is the central slide, so I'm basically spending a lot of time on that, sorry about that. It provides a consistent, non-repeatable history across all actors. In other words, there's lots of people involved. They're independent. Should they trust each other? Okay. So what this does, it provides a trustworthy platform, a technological platform for saying like, yes, the recorded data cannot be changed by anybody. And the economic resources are preserved. So you cannot produce 2 liters of virgin pressed olive oil out of the same number of original grapes, which has been done in quite a bit of time when we do resource tracking. So the platform guarantees it's not possible, okay? So that kind of cheating or error is not possible. So, and then, it could, depending on what you do, this is very often, there's very different. It could either guarantee high levels of privacy or no level of privacy, okay? So there's different ways of looking at this, okay? So the key thing is that the last part means that there's a symmetric access and control. So everybody who participates knows there's not a single party who's got a lot more control over the data, the processes. They cannot, stop your process and keep their process running and so on. It's really an equitable way of having these things running, okay? There's no single power. So this is very important. Sometimes if you have 3 competitors collaborating, they will usually not agree on one of them running the database server, okay? Because that gives them an advantage. So then there's secure tracking and tracing, which means like, the events are recorded, and from those we can put together, we can stick together, and I'll give an indication of that, and Lars will say more about this, how this is done for coffee. And no forging and double spending possible. So basically the platform makes it impossible to do at least that cheat, okay? You can still steal digitally. So all of a sudden you say like, I own this, but in reality you don't. But you can't duplicate the resources. So there is a couple of current favorites that are used widely. So the ones that are heavily used, these are so-called non-permissioned ones, and very, very expensive to run because they have to be, civil attack resistant, which means that they have to work even though people can give themselves 1 million identities. And it's very important to remember when people say anonymous is not, the most important part of anonymous is like, I can be any one of 1 million identities out there, okay? So if you only have one identity on Bitcoin, I don't know, you're a strange person, okay? So permissioned means that no, there is an access control, you get basically identified, and you have much, much more classical and much more energy efficient protocols. So energy consumption of these blockchain systems is way lower than the ones above. So, and there's build your own because you can show that there's no ideal one for all users. So why use this? So that's why, supply chain networks. So we have, producers, transporters, many halfway, manufacturers. So why should they be interested in blockchain at all as a technology? Well, let's look at the preferences. So you have usually many independent cooperating actors. They cooperate, they deliver to each other, but it's not like, one of them gives all the data to the next one. I mean, usually they prefer not to do that. So that suggests there's an interest in decentralization of having such a computer network. So nobody's really given, like privileged control over it. The practice is that right now we're seeing that a single actor actually controls the supply chain. So basically, if you're a dominant party, you might be interested in doing this, but maybe the other party is not so interested in having all the data. I don't know, a big automotive manufacturer wants to get all the data from not only their suppliers, but the suppliers' suppliers and so on. Or if you don't have that, you have no effective way of what I would call deep tracking. So not just, where do I get my stuff from my supply? I know that, of course, because, but if somebody finds a fault in the product I've produced, where are the original components coming from? Okay. Well, I can only go to my supplier. And then if I don't have deep access to all the data, it actually turns out to be surprisingly difficult in practice to find the causes, even though we have a lot of data available nowadays. So consensus and relevant. So in practice, very often it turns out you and I actually exchange things, but we record things slightly differently. Anas has received something from me. I've recorded that. Anas records it, but after a while, we find out you have recorded it slightly different in your database than me. So there is a lot of reconciliation inconsistencies. In practice, it's actually stunning how much work and manual processing there is in reconciliating events or data. So this is a single source of truth that's sometimes called, and the trustworthy auditing, of course, I don't know, you look at my database, I could have sort of like lost data or finagled it a little bit. So, that's greatly helped by tamper-proof recording. And many other things like, auditing could be things like, checking whether the food comes from. As I mentioned before, you want to make sure that people can't easily forge certificates or, make sure that it looks like it's a nicely, sustainably grown product while it actually isn't. So blockchain for coffee, just wrapping up now. So blockchain for coffee, we've developed a modeling framework. That's an extended framework from 80s, 90s, zero. So the key thing is like, we're working with different kinds of resources. Those could be money, or in this case, different kinds of coffee. The events, it's an event-based model. It says like, well, you can transfer, these resources like ownership, possession, you can transport them and you can transform them. And the transformation, it sounds abstract. It means like it's production, right? Some parchment coffee disappears and then some green coffee pops up. Think about it this way. This is producing, this is milling. It produces green coffee from parchment, from coffee and parchment. And packing, unpacking is basically the same thing. It's just like, I have a whole identified bag of coffee. I can even pack it together into a truckload and then unpack it again, and I can trace this back and forth. Okay. There's also observations. For example, you observe that a bag of anything or a truck has been observed. You scan it and you register that. There's tests of coffee quality tests, cupping. There's actor authentication that says like, an actor is actually certified to, for example, issue certificates to a farmer. All right. So this is the general framework, and we've applied it to the coffee tracking. But I hope you'll get an idea that this should be applicable and is applicable to tracking and tracing other things. The information is to make sure that we have a reliable way of tracking coffee from cherry to cup, you might say, from the original farmer to the final cup that you'll drink. So, and as I mentioned, the evidence could be anything at all that's associated with this, and it's tamper-proof. An implementation, decentralized platform for a coffee supply chain. We've worked this out with our project partners. So you can probably see this very nicely, but this is a web app. So it's a running web app. You can run it on your, on this thing, whatever you have, and see actually where, a product, maybe a cup of coffee, where it comes from. It could come from different sources because it's been blended and so on, and where it's been. Status, we have a database-based implementation, also one where Ethereum has been used as a backend. And we're preparing a pilot test where this is the digital platform that shadows, you could say, the actual tracking and tracing of some real coffee that is being shipped, will be shipped from Colombia in this case. And we're planning a web app demonstration, a public event to show this is applicable to the broad public. So I want to say at the end, thanks to the Kobe Foundation that made this research possible, and of course to our project partners at Chalmers, at Kobe, who are leading the managing project. at ITU. Peter Larsen Kaffe was an important, and you will see Lars later on actually, and our colleagues at both DIKU Computer Science Department at the Geology and Geoscience Department. And there's some contact information. Thanks.
I'll try to give a few perspectives as we see it. Now, SEGES is a part of the Danish Agriculture and Food Council, and our primary focus is on the farmer himself. So we do quite a bit of R&D, a lot in cooperation with the agricultural departments of the universities in Denmark, and also in other countries, but mainly focused on the farmer. So, and then we kind of check out when the farmer sends his goods off to the processing or food industry. But in recent years, also regarding the subject at hand, blockchain, but also the sustainability, carbon footprint, and so on discussion. Of course, you have to look at the full food value chain if you want to document what you do, if you want to optimize, your use of resources, lower your climate footprint, then you need to document all through the chain. But with our primary perspective being on the farmer himself, that is just a disclaimer. I'm not really from the food industry. I'm more on the agricultural side. That being said, as we look at it now, why? What is SEGES' why? I usually say it's to make farmers, Danish farmers, rich and happy. And if other farmers become rich and happy as well, that's fine with us. So if you look at it from a farmer's perspective, we have not yet come there where the farmer can see a significant effect on his revenue from like blockchain or other documentation technologies. However, we can see that the Danish export of pork to China has risen tremendously. So has it from other countries. This is not only due to blockchain, this is due to African swine fever in China. But still, we do believe that we have been able to access, if you could call it, the upper shelves in the supermarkets and in the stores, meaning that through a high level of food standards, food safety standards, veterinary standards, but also a high level of documentation, maybe our goods may be preferred in competition with others, but the competitors are tough, so they're biting our tails all the time. But we are still a ways away from complete documentation from farm to fork. But, and I guess this is almost a repetition of what Fritz was saying. It provides this clarification, this trust, and you have a number of countries. As a Dane, we have a general high trust of food quality, and we trust the Danish vegetables, meats, and so forth. Basically, we do, but not so in many countries, in emerging economies. So maybe there is an advantage there that can increase the trust and thus the price people are willing to pay for a product where you have solid documentation of origin, of footprint, and what have you. If we look at the Danish slaughtery co-op owned company, Danish Crown, they are clearly the primary drivers. We export about 80% of the pork we make in Denmark. It's necessary if you want to be an actor in the right price segment across the world, that you can document your goods, basically. And and also, I think the demand, I spoke to the vice chairman of Danish Crown a few weeks ago, and he said just 6 months ago, when you were talking climate footprint in agriculture, the focus was very much on the dairy and the beef industry. no one was talking carbon footprint with pork because they have, in general, lower carbon emissions. And in just 6 months with this climate change agenda as the driver, that has changed. Now everybody, every retailer, wholesaler is talking about carbon footprint also with pork and sustainability in a broader perspective than just the carbon footprint. And so I think the need to document we are actually not greenwashing our goods, our meat, but that we can firmly document that, yes, it comes from here and it has an impact of such and such a magnitude, is becoming increasingly important. So this is also why, plus there's a money issue as well, of course, investment issue, that they are the drivers. And clearly Danish Crown now are having an advantage of being owned by the farmers, and they own the processing, and so they can document quite a ways away through the food chain, and also with whomever they may cooperate with in the foreign markets, and logistically wise also. So of course, Danish Crown has been the leader here, you could say, the first mover in the Danish food industry, but also with Arla, the big dairy, DLG, Danish Agro, who are in grain and feeding, are also, well, there should be obvious possibilities. Even though if you take a piece of meat, you would know it would have to come from an individual pig. Whereas if you take a pound of cheese, the milk that has gone into the cheese and the processing can come from a number of cows. So of course, every branch in the food history or the food industry has a different story and a different background that they can build on. But still, with this issue being so high on the agenda, there still should be possibilities for it. So if I were to eat a Danbo semi-soft cheese, could I scan the QR code and get a video of the cow running around in the field or in the barn? Maybe. I certainly could with a piece of meat, because you should be able to trace that all the way back to the individual pig. And I think also that, or we think that urbanization and the further away many people move from actual agriculture and the farmer's perspective, the more worried they become. Maybe because of lack in transparency or lack of knowledge, the farmer would always say. The consumer don't know what they're talking about. They should meet us farmers. But still, I think this will also drive this need for documentation, that people are getting further away from where the product is actually produced, which is also why we see urban farming. But if you can't urban farm everything to feed the metropolitan areas, well, maybe you can have solid documentation that not only gives you the objective trust, you could say, but you can also add storytelling to it. And I think that is also a possibility to increase your value. IBM has actually surveyed a large number of consumers in 28 countries. So 8 out of 10 say sustainability is important. So if you can document a certain level of sustainability, maybe you can sell your goods at a higher price. And 7 out of 10 say they're ready to pay up to 35% more. Now of that I would be careful. A number of years ago, I think this was also Danish Crown or the Danish Pork Producers Council, I'm not sure. But anyway, they would do interviews with people going into the supermarket and say, so what kind of foods are you going to buy today? Are you going to buy conventional foods or organic foods or whatever? And a large number of people say, we're going to buy organic foods. Now, when they came out of the supermarket again with their carts, then the same person would stand there and see, can I see what you bought? And pretty soon they were threatened with getting beaten upon. So people are not always doing what they say they will do. But still, we have in Denmark seen a steady increase even through the financial crisis and also through Corona, actually. And more people are buying organic foods. And I think that is a global trend, at least in the Western world, in the wealthy countries. So maybe we can use, seen from a farmer perspective, blockchain to not only document origin, but also document sustainability, add storytelling, try to position yourself in the market. And not only blockchain, but digitizing agriculture overall, we see clearly the climate challenge and the agenda of climate change as a not only potential, I should have said driving force, because it is a driving force. Now, this could be a turning point for the commercial use, because not only can you be sure that all transactions are valid through the whole chain, but you can, as mentioned before, also have a much more solid documentation of what is my environmental impact, my climate footprint, and so forth. Is it organic? How are the animals treated? I mean, you can fantasize on and on. And I think this will be an important driver, because people will be worried with, are we greenwashing? Are we actually telling the truth? Yeah, this is very low carbon footprint, but have we greenwashed it on the way? No, and I think, so if you want to address an agenda like the climate change agenda, you should be very careful not to be caught in greenwashing or telling the story a little better than it is. And their blockchain technology can also help us in that respect. But for us, as we see it, it's only, it has great potential, but it's only maybe not a first step, but one of more steps that need to interact together. We think that development of decision support system concerning sustainability, climate footprint, resource utilization are essential first steps, or at least steps you need to take together with using blockchains, with the right tools to optimize your production, lower your environmental impact, make better use of your resources. And if we can put that into a blockchain so you can actually document, we took this action on the farm, we tried to optimize such and such, and the outcome was that we had this much yield at so low use of resources, and then put that into the blockchain. Then you should be in good shape going through the whole chain. So just to give you an example on how can we complement data-driven decision support and management, where we are going now from descriptive. Now we harvested our fields, the yields were so and so. What could we have learned for it? We can make a diagnostic approach to it. Well, it happened, but now we can't do anything about it. We can't change it. Moving into predictive tools, and then into prescriptive, with the prediction looking such and such, then you should actually do this at that time in that specific field, or to that specific cow or pig pen or whatever you have. And just to give you an example, in Denmark, with a sometimes cool and quite rainy summer, sometimes dry, it's hard to know when you're planting or sowing your grains in April or late March, how much do I sow per square meter? How much do I fertilize? Because if you have a wet and quite warm summer, the crop will stand very dense and it will be heavy. And when heavy rain comes, there is a risk for the crop falling over. And if this happens, like you see here in a wheat field, you have a loss of yield of about 20 to 40%. So that's quite significant. So many farmers will say, we will spray a growth regulation which actually shortens the straw and makes it more stiff, you could say, so it doesn't fall over as easily. But of course, it takes time, it's expensive, and you don't really want to use more chemicals than absolutely necessary. But many farmers say, we make a spraying plan, so we spray all the wheat fields, then we're safe. Better safe than sorry. We say, why don't we combine data from, we know the crop history, the crop rotation history on this farm, maybe 20 years back. We know how the weather has been and so forth. We have satellite images that we can transform into growth or crop density index pictures, so we know in which field are the crops dense and in which are they thinner. And combined with a large number of field trials many years back, we know where are the thresholds for the risk of the crop falling over. So without the farmers having to do anything himself, we can actually advise him that here on the green fields, if you can see my pointer, the risk of the grain falling over, laying down, is very low. In the yellow fields, it's medium high, and in the red fields, you should probably growth regulate. We still say, don't completely trust us. Please go out and look for yourself and use your experience and knowledge as a farmer. But still, we're trying to make this as a decision support system. Now, 2 years ago, he would have sprayed the whole thing, no matter what. Today, hopefully, we can ship data out onto his crop manager system that can communicate with the tractor's computer, that can communicate again with the sprayer. And it can also communicate back, so we can put into the blockchain as applied. Now, what did he actually do? He actually did not spray these green fields with growth regulation. Now, if this is wheat made for baking bread, then you have documentation that this was not treated. And we can do it automatically, maybe not right now, but it wouldn't take much to put this into the blockchain. Now, this is just one example. Of course, he has a number of actions throughout the growing season. But if we can combine these decision support technologies with how did he actually apply what he's doing in the field, put it into the blockchain, and then this is just one of many actions taken before the bread, the whole grain bread, is sitting out on the counter at the bakery or the supermarket. So yeah, thank you. This was just trying to give a perspective and how can we build on and add maybe even more value to where we combine decision support blockchain and hopefully get both better documentation, but also make the right and the most sustainable decisions. Thank you.
I will just give you a short, brief description of the work and the project that we've been doing within Peter Larsen Kaffe in order to explore these kind of benefits that we see from the blockchain technology. As Fritz probably already presented, we've been taking part in a rather big COVID project together with various universities in Denmark and Sweden and other players within the coffee supply chain. And just hold on. Just briefly, some of the primary objectives that we've been and are looking into. First of all, we're doing a quite a big job to identify and map what is already going on, existing, and also future potentials of using the blockchain. And with this respect, we look primarily into how we can increase our sustainability efforts. As you all know, I mean, working with coffee, we're working all parts of the world, you can say, working in more or less 50 countries gathered around equator. It gives us some kind of complexities in the ways of transparency and so on. But also we will try to see if we can develop a blockchain. Could we source our coffee and connect it to a blockchain system? We're also looking into the energy consumption and comparing the energy use of using the blockchain from what we are normally do. And then, of course, since it's a scientific study, and we are going to do quite a lot in terms of presenting our work, which is the part that we're kind of entering now. I mean, the project has been going on now for 3 years, and the part that we are now entering is that we will start sharing more knowledge and insights from our work. But looking into the just very like a very overall view, I mean, the Colombian coffee supply chain, which is the case that we've been looking into, and a very brief picture of the supply chain, and we see various business operations coming from the production at farm level, and the coffee enters various stations, purchasing points, and goes to dry mill and export, import, and ends up at our roasting sites in Sweden or in Denmark. And we see through that process, the coffee is changing character as it comes from being a coffee berry that is picked from the tree. It's actually being changed into coffee parchment and becoming green coffee that is shipped in duty sacks and ending up in our roasting sites, and we're roasting the coffee, and it ends up in the retail packages that we see. And actually that process, as we go along, is also, I mean, we are in the coffee business. We are quite, I would say, we have a very detailed, transparent system, but we have also some weak spots, and that's also something that has been part of the objective of this study. Is, I mean, can we trust the information that we have in our system? And that's actually still one of the biggest problems that we see. I mean, it's all dependent on humans. So all the information that we get in, I mean, if it's false at the first point, it's also what we end up with. So, but we've been carrying out some very detailed studies. We've been a project group been studying the on-site, the Colombian system, and we went to see some of our partners there, and went to see the farming sites and the various facilities in the Colombian coffee business. And I mean, basically what we decided to look into on forehand, and some of the issues that we wanted to describe in a blockchain were these use cases that we see here. And then as we went along, of course, much more information was available, and we could enter much more information into the system. But basically, these are the kind of informations that we would try to tie up in a blockchain. And we're still, I mean, we cannot say that we are all now we have this blockchain and we are all set, because I would say we still have a lot of learnings to do, and I would say the biggest question mark from the start is still what we consider the biggest question mark. Can we trust the information that we get into this? And also, we would say that it seems like a pretty expensive technology for the time being. And are we getting the efficiency out of that compared to the system that we're already running? And I would say this is I was a little bit what to share with you here, but actually I want to say that this is my presentation just to give you an idea of what we as a coffee company is considering about blockchain. But I would rather say that you're free to ask some questions if there are some things also related to what has already been presented that you want to ask me as a coffee professional about. I would prefer that.